Good afternoon and welcome to this seminar that the University of Las Palmas of Gran Canaria and the CIHEAM Zaragoza is organizing about aquaculture, nutrition in transition, efficiency, health, and sustainability. This webinar is an action that we are organizing in order to promote the master that both the University of Las Palmas de Gran Canaria and CIHEAM Zaragoza organized since more than 25 years, Master on Marine Aquaculture. For organizing this event, we have made our focus in some nutritional aspects of aquaculture, and for that we have invited some former students of the Master on Aquaculture that nowadays are already, in my opinion, well-known professionals. And before starting to present the topics that we are going to deal with today, just let me give you some indications. So the webinar is recorded, and after the webinar, we will upload the webinar in the YouTube channel of CIHEAM Zaragoza. Other things, we are going to have a set of 3 presentations, and at the end of those 3 presentations, you will have the chance to participate in an open debate with questions and answers. And for that, you will have to use a tool that Zoom is provided. Normally, it appears in your screen, in your menu, as a Q&A. The other thing is that the webinar is on English, but we are providing simultaneous interpretation from English to Spanish. And in order to follow the webinar in Spanish, what you have to do is go to the interpretation tool. Normally, it's like an icon of a word. And then you select the language. You can select just the original or voices, or you can select the Spanish and follow in that way the webinar in Spanish. Okay. As I say, I am Bernardo Basurco. I am an administrator of Fisheries and Aquaculture at the CIHEAM Zaragoza. And I am the responsible of the activities on Fisheries and Aquaculture and the responsible of coordinating what is our role in the Master on Aquaculture. From the University of Las Palmas de Gran Canaria, we have today the coordinator of the Master, Professor Felix Acosta. Hello, Felix. The microphone, Felix.
Sorry. Hello, Bernardo. Hello, everyone. My name is Felix Acosta. I am professor of the University of Palmas de Gran Canaria. I am the coordinator of the Master in Aquaculture, and I am the head of the Aquatic Animal Health Unit in the Research Aquaculture Group. I think that at the moment is the only information that you need from me. And Bernardo will continue with the presentation to know they spend a lot of time with presentations.
Okay, thank you, Felix. So we continue, and then let me introduce you the agenda of the webinar. So as I said, we are starting with 3 talks about different aspects dealing with nutrition. The first one is going to be Mohamed Sula, who's going to talk about aquaculture nutrition from a classical approach to a sustainability and a focused perspective in farming systems. Then we will follow with Rachid Ganga, who will talk about driving aquaculture sustainability through alternative feed ingredients. And the last talk will be given by Silvia Torrecillas about functional additives as effective tools to enhance aquatic animal health. As I say, they are going to talk for about 20 minutes, and then we will have some time for questions and answers. And then at the end of the webinar, we have some time just to introduce you the Master on Marine Aquaculture. That is the program that we have for today. And so let's start. Let me pass the floor to Mohamed. So you can please share your screen. And well, as I said at the beginning, the 3 speakers of today, they are former students of the Master on Aquaculture, and they already have a long career in this specialty. Mohamed is working as a consultant at Cargill. And just Mohamed, please take the floor.
Yeah, you are seeing my screen?
We see your screen.
You're hearing me well?
Yes.
Okay. Thank you, Bernardo. Thank you for inviting me today. It's a pleasure to back again in CIHEAM and try to support in this promotional meeting. Thank you all also we have a lot of people today with us. I will try to talk about aquaculture nutrition and really how we are moving from a classic perspective to really focus sustainability perspective in the last years. No, first of all, I will try to give a little bit of background of who I am. It will be quick. I'm Tunisian, coming from the Institute of Agronomy of Tunisia as an engineer, and I have the chance, as Bernardo was saying, to be part of the master from 2004 to 2006, and from that I think start an aquaculture specialist with the PhD in aquaculture, and the last 10 years I was working around the world a little bit, working in production, in R&D, in feed management and feed additive. And today I'm the aqua technology consultant from Cargill, animal health and nutrition, animal nutrition and health mainly. And we are supporting globally our team and also our customer to improve formulation, to improve feed performance, and to get the best quality of feed that we can work with and to share to the customer that we are working in Middle East and the rest of the world. Yeah, this is mainly who I am. I think today the talk is really interesting, and we need to understand one thing, that nutrition is one of the powerful lever in the aquaculture. It's really impact biology efficiency, fish health and robustness, the environmental footprint, and of course with this, its clear impact to return of investment or the economy of farmer and they can say feed miller in general. No, as you know, feed is the largest single operation cost in aquaculture, and generally we are saying that is representing between 50 to 70% of the cost. So when we are improving nutrition or we are dealing with nutrition, we are not just improving the fish growth. We are improving the entire farming system and farming economy. No, that's why I think that nutrition today is not longer just a formulation step. It should be a strategic tool for the aquaculture sustainable growth. For many years, aquaculture nutrition was mainly built in a cost-driving formulation, where the diet was mainly formulated to be a cost efficiency first, and where we are prioritizing raw material rather than nutrient efficiency and sustainability. No? The main focus was to really reach a better growth and improve the feed conversion rate. This was the main KPI of any aquaculture system or any aquaculture farmer. No? But also in this period, everything was limited to what we have in the feed, and we are not thinking too much about the farming system. We are not thinking about sustainability, but maybe today it's really clear that this is not the context that we need to carry on in. No? And this is because there is several forces that are pushing aquaculture nutrition to change, no? The first thing is the pressure that we have in the raw material. We have limited availability of fish meal and fish oil. Also, we have a volatile price that is impacting too much the cost. And we know that also the environmental footprint is a major constraint. Also, when we are seeing what's happening with the climate change in the world, the increasing of temperature, also the extreme event that we are seeing, and this is requiring really a nutrition that can support better the resilience of the fish and the adaptive performance that we can get. Also, we are moving, or we have moved during the last 30, 40 years from semi-intensive or extensive to really high intensification and the development of different system of culture. And this is really need also an adaptive nutrition that can support the resilience to this new system and the clear stability on, for example, on RAS or anything else that we are working with now. And finally, we are seeing from the consumer, from the regulator, a clear demand and need in transparency and sustainability. And this is something that in the last 10 years is need, and we are moving in. No? If we look at the feed formulation over the time, we clearly see a transition from a conceptual feed that involve a static recipes to really dynamic nutritional system. No? In the 90s, we was mainly focusing in formulation in crude protein and energy. We are using marine-based feed, and as I said before, focusing in growth and FCR. And in the 2000s, mainly, we start to see more focus and more focus on digestibility nutrient and better utilization of the resource, and more consistency in the nutritional that we are using, and less marine dependency. No? In 2010, more or less, we are starting to see life stage feeds really defined, a functional nutrition and direction to really health and robustness, because it's needed at that time. No? And we are going to try to work with the feed with reduced waste, with more nutrient efficiency. And in the last, I can say 7-8 years, we are going more in precision nutrition and site-specific system and sustainability-driven nutrition. And this was mainly highlighted by the FAO in 2023. No? They are saying that maximizing the growth alone is no longer enough to improve the aquaculture. Nutrition must now support system resilience, need to reduce environmental impact, and also improve predictability under the variable condition that we have today. No? This is really lead us to a concept of smart nutrition, no? Which is meaning that we need to go to feeding fish better, but not more, using nutrition to optimize performance, resilience, and sustainability. We need to adapt feed to the farming system, but not forcing a system to be adapted to our feed. And with this, I think nutrition became a system level decision, not really just a feed label that we have there, protein, fat, ash, and fiber. No, this is something that should really evolutionate on that. No, that's why I think that the smart nutrition should be built in 4 pillars. The first one is a clear nutrition precision that where we can meet the real fish or shrimp requirement and minimizing as much as possible the waste in the environment. The second thing for a smart nutrition should be a clear match and adaptation to system production and feeding system, whatever is the system that we are working with, RAS, cages, or ponds, etc. No? But also it's really important to work in a functional nutrition, not only in ingredient, but also in nutrient that can support gut health, can support immunity, and can support stress mitigation that we are seeing by not only by the environmental change, but also by the management that we are getting in our farms. No? And finally, the fourth pillar is a sustainability, the use of alternative resources. And I think this will be more developed after by Dr. Rashid. No? The transition from a classical nutrition to smart nutrition has led to clear emergence of new feed concept. And this is really across all the aqua feed industry. No? Aqua almost, I think, 6 months ago was launching trace element feed concept to really go a precision in terms of the trace element that is including in the formula. I think 1 year ago, something like that, Scrating was working and launching Aminova to get really maximize the impact in terms of performance, but also reducing or minimalizing the waste. And in Cargill, we are working along the year in different alternatives. And two of them, I will try to explain it today, which is mainly essential nitrogen and effective energy. That our idea is to dive into new world of precision nutrition. And this is where normally we are thinking to go. No? For essential nitrogen, really represent a major concept shift. No? Historically, we are formulating from feed around protein level, fat level, but as per our understanding, fish do not need protein. Fish need nitrogen in the right form, in the right quantity, and in the balanced way. No? Our concept is really partitioning digestible nitrogen into specific nutritional entity. We are focusing more in nitrogen utilization efficiency, and we are separating anabolic nitrogen from energy supply. This helps us to convert nutrient into biomass more efficiently instead of wasting the excess of nitrogen that we can get with a high level of protein. The impact of essential nitrogen is significant. No? We are lowering nitrogen excretion, reducing eutrophication and toxicity in the water. We are maintaining or sometimes improving the performance with lowering the protein level, which is the most costly. No? And we reduce the health issue, including the gill irritation that are usually linked or in some cases linked, to poor nitrogen balance. No? But also we are producing more competitive diet. We are combining performance and cost control. If I can conclude what is essential nitrogen is really an alignment between biology, economy, and sustainability. No? But we didn't stop at this point. And the next level in our work was launched almost 1 year ago. And our main senior scientist said that effective energy, which is our now new concept, mark the next step in our journey toward precision nutrition. No? While what I am speaking about before was essential nitrogen optimize the balance of nitrogen nutrient, the effective energy take it further by incorporating digital tool and real world data to refine nutrition planning. To explain it better, effective energy is a system level nutrition framework where we are integrating tank trial, commercial farm, and field formulation data and combine it in a scenario planning and digital tool to adapt nutrition to a geography where the fish is producing, the fish size, environmental condition, and economic constraint. No? We are trying to integrate all this to enable really a site-specific data-driven nutrition. And this is our aim, no? For the next mainly year for a predictable and sustainable aquaculture.
Hello, Mohammed. 5 minutes.
5 minutes, yeah, I know. Nutrition today cannot be separated from feeding technology. It's clear. Modern farming are using behavioral camera, sensor for oxygen, temperature, turbidity, and many other things. No? And we have a clear adaptive feeding algorithm for each company that we are working with. No? These tools really help to improve FCR, reduce waste, lowering also the metabolic stress in some cases in RAS and in cages. And the most important thing are providing predictive insight for growth and nutrient demand. This is really, we are going in a decision system, not only a feeding system. No? And with the digitalization, we are also transforming the health management. The data integration is helping us to early detect stress and suboptimal condition, which meaning that we have time to predict and adjust nutrition for the animal or for fish need in general. No? We are working in preventive nutrition rather than reactive health strategy that we are making in companies. No? Mainly for this, I think it's a, considering the interest of this webinar, I think it's important for the student that they are hearing us or the young professional that this transition is really will have a clear impact in what they have to do in the future. No, they need to master really not only in biology and nutrition physiology, but they need to have a clear learning about environmental science, about data analysis and digital tool. Also, they need to get a clear background about sustainability assessment, because will be a future of the aquaculture. No? Just to conclude, for me, aquaculture nutrition have really to move from a crude formulation to digestible nutrient to a precision and system-based nutrition. And I will finalize by a clear wording. Now, the future of aquaculture will not really depend on producing more fish, but I think that we need to produce fish smarter, in more efficient way and more sustainable way. No, this is last word. I think I am in time. Thank you so much for your attention, and happy to get any question if needs.
Okay, thank you very much, Mohammed. I think that you have made a very good introduction, focusing on, well, making a review of what was the main focus on nutrition and see how we are paying more attention to more, not only other aspects, but to a more holistic approach on aquaculture. Well, I remember to the participants, if you have questions, you may post it in the chat, but also in the questions and answer tool. We will have time for discussion at the end of the three presentations. So we continue, and let me share my screen. Okay. Do you see my screen?
Yes.
Okay. So let me give the floor to Dr. Rachid Ganga, also a former student of our master. And nowadays, after doing the PhD and being in several places, he will tell you, he's already back at his country in Agadir. So, Rachid is going to make a presentation about one of the main points addressed by Mohamed, that is the need to work with sustainable and alternative ingredients on aquaculture. So, Rachid, whenever you want.
Okay. Thank you so much, Bernardo. I would like to start by thanking Instituto Agronómico de Zaragoza and the University of Las Palmas de Gran Canaria for putting together this outstanding webinar. I would like to thank particularly Dr. Bernardo and Dr. Bernardo Basurco and Dr. Felix Acosta for what they do for new generation of students pursuing their dreams in aquaculture. Next slide, please. So since I was asked to put together these slides, and Bernardo told me it's going to be for future students being interested in international masters in marine aquaculture, I thought that sharing my journey would be useful for them. So I'm originally from Sidi Ifni, and this is in southern Morocco. It's a small fishing city. So I was in touch with fish and fishing since I was a kid. I graduated from Institut Agronomique Vétérinaire Hassan II in Rabat in 2002 as an engineer in fisheries and aquaculture. And I had the immense opportunity to join the master in Las Palmas. I graduated 2004, and then I completed my PhD at the same university in 2010. And since then, I have had the opportunity to work in the industry in Northern America. So I had the opportunity to work in different R&D roles at Aquaculture Canada, Center for Aquaculture Technologies in Prince Edward Island, Canada. And then from 2016 to 2022, I worked at Tyson Food in US at their Tyson Discovery Center in Springdale, Arkansas. And of course, one of the biggest challenges for developing countries is their talents, with going and moving to developed countries for better opportunities. And then after 20 years abroad and pursuing a more meaningful career, I decided with my family to go back to Morocco and trying to help the industry, and also opening opportunities for my students to pursue their dreams in aqua. So I hope that the journeys shared by the speakers today would inspire students attending this webinar to go out of their comfort zone, take risks, and pursue their dreams. And this master's has changed my life and had opened many opportunities to me, and I encouraged them to pursue this opportunity. Okay, next slide. So I just put together, since this is mainly for students, without getting too technical, sorry, I thought that I would just give an overview by introducing the challenges we have to produce more food for a growing population, some insight into aquaculture industry growth, changing dynamics in terms of aquafeed ingredients, and touching on some topics of sustainability and novel ingredients for future aquafeeds. Next, please. So I'm sure you have seen this slide many times. So we have a big challenge to produce enough food for growing populations. Where all the expectations is that world population will achieve 10 billion people by 2050. And the way we have been producing feeds in the last decades has been damaging our planets with global warming as an indicator, but also over exploiting the world resources. Next slide. But when you really dive in and see where our food is coming from, so actually planet Earth is, I don't know why it's called planet Earth, it should be called planet water because it's only 25% Earth. But when you dive in how much of the land is used actually to produce our food and feed, it's only 3% of the planet's surface. Next slide. And of course, knowing the damage we have caused to our planet and knowing that producing more food would also put more stress on the planet, I think as a humanity, we have agreed that we need to stop the global warming, and the international community have agreed that we need to limit the global warming to 1.5 degrees C by 2050. Next. And that was achieved through the Paris Agreement in 2015 and 17 United Nations Sustainable Development Goals have been agreed on. Next. Hoping that if all these SDGs are respected and the goals are achieved, we would achieve carbon neutrality by 2050. Next. So this is a big challenge for all of us. So feeding 10 billion people, if we compare how much food we need to produce compared to 2010, we need to produce 70% more food without using more land, and we have to lower our emissions by almost 70%. So we need to be very creative and have a revolution in terms of what in terms of innovation and food production systems to achieve those goals. Next. So when we come back to aqua, so aquaculture is the fastest growing animal production sector, and it is expected that this growth will continue in the next decades, but it is expected that we need over 50 million metric tons of new raw material to produce the extra feed needed by 2050 for aqua. Next. Of course, aqua, when you think about it, it's a diverse industry. It's over 200 species all over the world. And these species are different in terms of the requirement and in terms of what kind of feed, protein composition, and feed formulation you can use, what kind of ingredients. Next, this is an example, for example, and there are a variety of feed ingredients used. So Dr. Sula has touched on it a little bit, and thanks for that. So there is ingredients coming from fisheries, ingredients coming from agriculture, and ingredients coming from other animal byproduct processing and upcycling industries. Next. So as in feed manufacture, aqua feed manufacturing world, we have some nutrient requirement for the species we are formulating feed for, depending on the species, the life stage, farming management systems, etc. We have a basket of raw materials that we can use to satisfy those requirements. Of course, we have different feed processing technologies. We have all kinds of additives that we can add to improve, feed performance. And also, we need to watch out what these dietary effects are causing to our production system, to the environment, etc., etc. Next. I particularly like this slide from Dr. Bureau. So producing cost-effective aquaculture feed. So we have some steps we need to take before, go ahead and produce the feed. So we need to define our objectives, what kind of feed is needed, understand the animal. This is understanding your animal in terms of species, the environment it's in, your production goal, etc., etc. Characterize the ingredient composition and nutritive value. So Muhammad has touched on this. So before we just think about crude protein. Now it's a different world where we are living in. We need to be more precise and be more smart in terms of not only looking at ingredients, but looking at particular nutrient and their performance in our production system. We need to optimize feed formulation and specific production objectives, and there is all kinds of tools available today to make life easier for feed manufacturers. We need to manufacture the feed, and then, of course, we need to have a feedback in terms of having an idea of the performance, what our objectives in the beginning, and if these objectives were achieved in terms of performance, working with the farmers and consumers. Okay, next. There is this particular database that I like and I recommend to my students, where you have aquaculture, a large database in terms of aquaculture species nutritional specification database, feed ingredient composition database is used all over the world, and this may save some because doing analysis is expensive. So having these tools for all over people to be used all over the world is quite very useful, and I recommend it to my students. And there is also recommendations in terms of practical aquaculture feed formulations for the main or the major aquaculture species. Next. Sorry, Bernardo. Okay, so Dr. Shula has touched on this very well. So there is a history of how the aqua feed ingredients have been shifting and their dynamics compared. If you look at the aqua feed before 2000, we had plenty of fish meal and fish oil, and the industry was not that big. So fish meal and fish oil was the main ingredient used back then. But since we have overexploited or reached the maximum of fisheries production in terms of fish oil and fish meal, there is a lot of problems related to availability of these strategic ingredients, and also volatility in terms of the price. So price is very important when you are formulating in a least cost formulation basis. So there was a shift between 2010 and 2020 where fish meal and fish oil have been significantly reduced and used only as strategic ingredients. A lot of fish meal and fish oil have been used coming from trimmings in terms of instead of whole fish, and plant ingredients have taken significant percentage in the feed formulation. And now when you look beyond 2020, there is more talk about precision nutrition, precision farming, nutrient requirement interaction, reduction of waste, and other sustainability metrics. Next. So this is explained again. So you see the shift in the 90s. There is 80% of the formulation is fish meal and fish oil, and today it's below 20% the total. And other novel ingredients are taking more importance. Next. Also species-specific ingredient use. So you see the same manufacturers. So depending on the species, they have the capacity to use some ingredient or others, or the claims for the nutritional value of the finished product and the consumer preferences. You do see some differences in terms of the basket of ingredients you can use and the inclusion levels. Next. Same market, for example, in terms of salmon, there is different legislation in different countries. So if you have a salmon from Norway, there is no GMO, no land animal byproduct, even though it's approved, but consumer perception is different. It's totally different from a salmon or aqua feed for salmon in Chile or in Scotland, depending on the market, geographies, and the claims as well, for example, in case of Scotland. Next. So now there is this notion of precision nutrition that Dr. Sola explained very well. So it's more using nutritional modeling, knowing the environmental factors and gathering all the data to be used in making the decision as a fish nutritionist in terms of formulation and precision feeding systems, feeding formulation that is more adapted in terms of specific nutrient, but also using new technologies, data of like a lot of data, and then also it's artificial intelligence. Next. So now we have to look for nutrients. For example, some key strategic nutrients like omega-3s, like EPA and DHA. We cannot get them from fish oil, so we need to go and develop technologies to produce them. And this is the case, for example, for producing EPA and DHA for microalgae. Next. That's used today in the aqua industry, and looking for all other biological systems that are happening in nature and how can we replicate them in the industry. Next. So you see a lot of products are today available. DHA and EPA are available from heterotrophic microalgae in the industry. Next. Or from genetically modified organisms, like in plant in this case. These are some of the examples of EPA and DHA from genetically modified plants. Next. Also, in terms of protein and other nutrients, there is the rendering industry. Since I worked in that industry, I am a big advocate for using these ingredients. This industry is very mature in, for example, in US and in Europe, and the products are used all over the world. But developing countries, they have a lot of opportunities to recycle and use these valuable byproduct and upcycle them to high value ingredients for aqua, pet, and other animal feed processes. Next. So the rendered animal byproduct, they have big advantages: highly digestible protein and variable nutrient, better balanced fat and amino acids. Raw material are sourced from inspected facilities, so there is there is full traceability supply and steady and supply and sustainable supply as well. Okay, next. So these are examples of meals and fat used today in aqua and other animal production systems. Next. So what the future development opportunities would look like. So this is a collaborative effort between the nutritionists, the formulators, the sales and marketing and procurement to develop sustainable feeds to sustain the growth of aquaculture. Next. So there is plenty and variable novel aqua feed ingredients available, but the key criteria to develop these novel ingredients, so they need to bring nutritional value, they need to be available in terms of volume, have a minimum volume that they can be used in the feed formulation, and that volume has to be steady and consistent in terms of quality. Of course, fish health and welfare, these novel ingredients have to bring benefit and don't, even though we're looking about performance in terms of growth, etc., but some would have more claims than only growth, and we need also to watch out if these ingredients are not causing any feed or food safety issues. Sustainability claims are nowadays very important, and also, of course, price. We are formulating in a very competitive least cost formulation world, and the value has to be justified. Next. There is opportunities also to reduce, redesign, reuse, and recycle, and everyone is watching out to reduce their carbon footprint, their water usage, reducing waste, etc. Next. And of course, sustainability and greenhouse gas emissions are a big topic nowadays. And if you look at the next slide, please, especially scope 1 and 3. So you do see that in terms of feed, for example, almost 45% of scope 3 greenhouse gas emissions, the impact is coming from sourcing feed ingredients. So we need really to watch out where we are sourcing our feed ingredients, if they are so far from where we are producing, and all the impact that may cause in terms of reducing or increasing our carbon footprint of our products. Next. Okay, so some novel in conventional aquafeed ingredient use. So you will hear a lot about single cell proteins, algae and insect meals. Some are some examples here, like using a methane, which is like a greenhouse gas, using it and recycling it to produce a product that can have a value, but also reduce our impact in terms of carbon footprint. So we do see a variety of projects and also companies working in these topics. And some of them are mature than others, but this is the way in terms of R&D and developing food, novel feed ingredient. Next. So I am sure that a lot of people have been talking a lot about insect meal lately. So this is, for example, the projections from Rabobank that by 2030, which is soon, the insect meal production will reach 200,000 metric tons, which is going to be absorbed only by aqua and other animal feed sectors, like animal pet food is already using a lot of insect meal in North America. And the model is like you are upcycling some organic waste to reduce waste, but also creating value in the end. Okay, next. And there is also some other emerging aquafeed ingredient like corn fermented protein, fermented soybean meal, barley protein concentrate, etc., etc. Next. Oh, Bernardo, you are sharing a different slide, different screen. Sorry. Okay. So this is, for example, this new novel ingredient, current volume potential, etc. The cost is very important. Also, the digestibility of the ingredient itself, and volume and consistency of quality of the product. Next. Okay, so as a take-home message, I think that sustainability will be a key driver in aquafeed to help achieve the SDG goals, and everyone is claiming these SDGs in their sustainability report, etc. Transparency and responsible sourcing and farming supported by certification schemes will be becoming increasingly important. So innovation is key. That's why all these feed manufacturers, they have the brightest scientists in the industry, the best qualified lab, etc. So the sector must develop and adopt sustainable raw materials to support the continued growth of aquaculture, and touching on circular economy approaches by exploring the potential of local ingredients, including rendered byproducts for developing countries and models to upcycle organic waste. And the main objective here is to support your customers to achieve their sustainability and profitability goals. Okay. Thank you so much for your attention, and good luck for all the students joining us today. We'll be happy to answer any questions later on. Thank you.
Thank you very much, Rachid. Really a very good presentation about how this war about the ingredients is so complex, is evolving, and how the sector is trying to respond to the new demands, and also adapt to the constraints, and the limits that we have on different productions. Just to point out before we pass to the next presentation is that Rachid has made a technical presentation, but the reality is more complex because all this use of ingredients is also conditioned by the legislation and regulations at international level. Maybe later you can say something about that. Okay, let me stop sharing my screen. And now I pass the floor to Silvia. Silvia is okay. Okay. So
El micro, Silvia.
Ahora.
talking about, well, while you are sharing the screen, let me introduce you. Silvia is, again, a former student of the Master of Aquaculture. Now, after doing the PhD degree and working as a researcher in the University of Las Palmas de Gran Canaria, he went back to his land, to Catalonia, and nowadays he's working at the IRTA as a researcher specializing in fish nutrition and health. And today he's going to talk about functional additives as effective tools to enhance aquatic animal health. Hello, Silvia, you have the floor.
Yeah. Well, first, thank you for inviting me to join this webinar. So it's a pleasure to collaborate with both the University of Las Palmas and CIHEAM. It's always feeling like going back home. So thank you for inviting me. And today, just as an introduction, explain you a little bit about my scientific trajectory. I started my bachelor at the States in Fairleigh Dickinson University in New Jersey. And after that, I'm working a year in aquaculture and in a trout hatchery. I moved to Las Palmas to take the master's in aquaculture. And I had the chance to do my master thesis with the company, and after that I continue with an industrial PhD sponsored by that company at the University of Las Palmas. I continue work with the University of Las Palmas in an industrial postdoc, and afterwards I come back finally to the university as a postdoctoral researcher, and after that I continue with several programs of excellence awarded by the Spanish government. Like 4 years ago, I was granted with a Ramon y Cajal grant, and I moved back to my home in Catalonia. So, well, I came back to the same slide that Rashid shared before, but it's important that you have to take in mind that it's predicted to go up to 11 billion of persons in some years. So this population growth, of course, will have an effect directly on the consumption of aquatic food, because the dietary trends are changing. People is consuming more aquatic foods, and for the aquatic food that is fed, because we can produce also unfed organisms as bivalves, for example, or algae. But for that ones that we need to produce aquafeed, it will be an increase on the volume of production. I don't know if I remember well what Rashid was mentioning about that we will need 50 metric tons extra of new raw materials. This increase on aquafeed production must maintain the quality and the composition of these aquafeeds. And as Rashid was explained very clear, aquafeed composition has evolved a lot from the 90s, with almost 70% of fish meal and fish oil, towards now or the very close next future, where we are reducing traditional marine raw materials down to, in some species and for some development ages, we can go down to 5%, and we are including not only these plant raw materials that the sector has been working on for a long time, but also novel ones, as the insects, as the single-cell proteins, microalgae. But the important thing here is that we must maintain palatability, the welfare, the health, and the quality of the fish we are producing, because we are in a new era. We are talking about precision nutrition or smart nutrition. So we are moving from ingredients to nutrients. And that's a concept that you have to have clear if you're going to be working on the aqua nutrition sector. But the changes on formulations, this is the typical case when long time ago, some decades ago, there was we were starting to work with substitution of marine raw materials with with plant materials, and there was a clear effect on the health of the fish, and particularly on mucosal health. When you were feeding high levels of these novel ingredients, it was quite evident the effect on the inflammation in the gut. The type of lipoproteins were changing depending on the oil source. So it was impairing, in some cases, the lipid transport, and you will finding these big droplets within the enterocyte, and also the junctional complexes in the gut were more exposed. So altogether was facilitating disease susceptibility. And situation climate change, ocean level rising, ocean acidification.
Silvia,
Directly on the pathogens.
Silvia, I think that I'm not listening to you.
But also there are reemerging.
Rachi, do you listen, Silvia? No, Silvia, please. Silvia. Silvia.
Silvia.
Silvia.
Yeah. Pathogen interaction change.
I don't know.
Facilitating disease outbreaks, and altogether in a context of
Silvia.
antimicrobial resistance, we have to limit the use of antimicrobials.
Elis, ¿tienes el teléfono de Silvia?
We are not hearing you. No te estamos oyendo, Silvia.
No, a ver, activa el micrófono. Activa el micrófono, a ver.
Pero parece que ella tampoco nos oye a nosotros.
Ya, eso es lo que veo.
¿Ahora?
Ahora sí.
Vale, ha muerto el micrófono. Vuelvo. Venga.
Sí.
Lo siento. Vamos. Aquí. Sorry about that. It seems there was a problem with my micro. I hope you are hearing me now. Well, yeah?
Yes.
Okay. So I was telling that I don't want to be pessimistic with the situation we have now, but all this global warming and this ocean acidification change pathogen dynamics, and it will appear new pathogens, emerging ones, but there are also some pathogens that are re-emerging. And it changes also the host response. So the host pathogen interaction is changing altogether in a context that we must reduce therapeutic use. We have to be very aware about the antimicrobial resistance. And in this scenario of intensification, diversification of aquaculture, climate change, the use of functional feeds as preventive or proactive tools to reduce disease outbreaks in aquaculture can be part of this solution. So, as you know, we can use prevention as a tool through functional feeds, because immune technology, within immune technology, vaccination for sure it's the queen on these tools, and it's the most effective tool to prevent disease incidents. But also immune modulators help to produce more robust fish, and not only that, also in some cases can help to boost vaccine efficiency. So within this context of precise nutrition, smart nutrition, we have the nutritional immunomodulator and immunonutrition that can help us in this scenario. So the European Food Safety Authority says that feed additives are products used in animal nutrition to achieve an effect on the feed itself, on the animals, on the food products that are consuming this feed additive, but also on the environment. And among them, there are several additives, and they are well classified by this authority. but some of them are immune stimulants that are the main effects are to boost immunity. Bicellular and humoral factors, also they increase vaccine efficiency, acting as adjuvants, and they balance mucosal tissues associated microbiota. And at the end of the day, they help us to produce more robust fish, and somehow we are reducing disease incidence. But some of these immune stimulants, because of the effects I just detailed, they also help to increase performance and productivity, as well as to reduce stress or the perception of stress, increasing fish welfare. So I will give you some examples of these products and some studies that have been carried out at the University of Las Palmas. Some of them are part of master thesis. So if some of you are enrolled, you will have the chance of running this kind of trials, because this University of Las Palmas de Gran Canaria is collaborating with the industry directly. So that's one point that you have to take in mind. The first products I will give you just a brief overview are organic acids. Organic acids are non-nutritive carboxylic acids or its salts. I mean, sometimes they are provided as blends, but they must be protected or in the salt form, because they must resist the pH of the stomach when they are fed to the fish. Probably the most studied one is butyric acid or butyrate. And in general terms, what organic acids do after being fed, it's that through several mechanisms, cell signaling or serving as an energy source, they promote gut health. They increase also not only local innate immunity, but also systemic. They modulate the gut microbiota by promoting the growth of beneficial bacteria, and they also help in food preservation. For example, formic acid has been used on the animal nutrition sector for a long time as a preservator of the feed. So this is an example of a study run at the University of Las Palmas facility with bream. And in this case, bream was fed at 0.3% for 8 weeks. This combination of formic acid and sodium formate. Despite there was no effects on growth or food conversion ratio, neither on the general or selected immune parameters, when we challenge the fish by intraperitoneal injection, feeding this product reduced the mortality significantly compared with the control group. So it was increasing the robustness of this fish species. But for example, when these organic acids has been fed to other culture animals, and in this case is banamate, no matter if it was microencapsulated in the organic form or as their salt, there was no effect of protection when was fed for 63 days before Vibrio paramenomyticos challenge. So that means that also we have to take in mind the nature of the animal we are feeding, how they feed in the feed, and also the composition of the product we are feeding. Another big group is prebiotics, probiotics, symbiotics. We have also postbiotics and other biotics, but I will define just prebiotics, probiotics, and symbiotics. And the first one are considered as non-digestible oligosaccharides that promote the growth of gut beneficial bacteria. In general terms, they enhance fish performance, promote immunomodulate the fish, increase the digestive function, because as you will see later, they have a clear effect on the structure of the villi and the microvilli, and modulate the microbiota. In the case of the probiotics, which are microorganisms that can confer health benefit to the host, are administered alive or head inactivated, there are a lot of species, gram positive and gram negative, that have been demonstrated to work properly when fed to fish, they increase fish performance. Also, the effects are quite similar to prebiotics, as I was telling before, but they also, in some cases, improve the digestive function. For symbiotics are a mixture, a combination between both of them, probiotics and prebiotics. And in theory, they will enhance the beneficial effect of both of them. But there are some cases that you can find also antagonisms. It's plenty of literature regarding these topics. So I just paste here some of the studies, but you can take a look on some databases, and you will find that it's a powerful tool to be used in aquaculture. Here, an example with prebiotics, also in a study carried out during the master thesis at the University of Las Palmas. Here, we were feeding mononucleosaccharides to bass for 8 weeks, and after that, we inoculated the bass in the intestine with Vibrio anguillarum. And we only not inoculate, but also we stress the fish to facilitate paracellular translocation. And as you can see, this mononucleosaccharide was protecting the fish against this Vibrio anguillarum in just infection model, but also when the fish was infected and stressed. That's why we look a little deeper on some of the effects of this kind of probiotics. And a typical effect is the potential effect on mucosal health, and particularly on gut health, but also skin and gills, because they used to have a clear effect on mucus production because they are changing the microbiota, and then it's changing the composition of the mucus and the rate of production also. And as you can see here, we were not only producing more mucus and from different quality, we were also protecting the microvilli and the jejunal complexes. So when we were inoculating the fish with a pathogen, the entry of the pathogen through the gut was more difficult. That's why the effect of this product in this case. But there are another effects in this case is a probiotic, and even you can feed a probiotic for 70 days with no effects on growth or survival or any skin mucus associated biomarker. You can take some skin mucus of that fish fed with dysfunctional additive, and in this case they found that there was an inhibition of the growth of a potential pathogenic bacteria of this fish when they were feeding with this yeast. Other big group of functional additives that is quite cheap. Remember one slide from Rashid, money, and it's quite cheap and it's quite effective.
Silvia, 5 minutes.
Yeah. Vale. And there are 5 phytogenics, and they are plant extracts and essential oils rich in biological active compounds. And besides all the effects we described for prebiotics and probiotics, they also have some sedative properties in some cases. Here is a case of salmon fed with these phytogenics, and there was an increase of almost 25% in survival when was challenged against Pseudomonas and Bolethida. But all that glitters is not gold. I mean, functional additives work in the proper dose, inside the proper formulation, but there are some things that we have to take in mind. The duration of the trial, product composition, the consideration of the basal diet, the synergies, antagonists, and also the effect. Where is this product causing the effect in a systemic or in a particular tissue? So, for example, one thing that you have to take in mind if you're working with these feed additives is that you cannot assure that your product will increase the survival against a pathogen just because your endpoint is a cellular or immune biomarker. It doesn't mean that if you're inhibiting the growth in vitro of one bacteria with the mucus of that fish, that doesn't mean that it's going to survive. The survival rates are going to be higher when exposed to the pathogen in a real challenge test. And the same with the broth. If you have a problem with a new raw material in a special area of the or region of the gut, you must choose the appropriate feed additive that will be not only tissue specific, but also region specific. And here is an example of a study run also at the University of Las Palmas, where we check the effect of a prebiotic and a phytogenic on the gut of European sea bass. And we see that the prebiotic was working along the whole gut of the fish, but the phytogenic effect was limited to one region of the gut of this fish species. Same for the mucus production. Galactone and monoligosaccharides were working also in the post-ileorectal valve segment, so giving a wider protection of the fish when was fed compared to the phytogenic. And indeed, there are antagonists, as I told you before. Be careful when you are working in a company and you are including on your health package a new feed additive, because there are antagonists. This is the case of combining this prebiotic and phytogenic, where the gut was totally inflamed. There was an inflammation process, and the microbiota was totally changed because there was an antagonist between both products. Same in this case with tilapia and a mixture of yeast, echinacea, monoligosaccharides, beta-glucans as a symbiotic. And then, as you can see in the graph, the symbiotics worked very well, similar to norfloxacin, to the antibiotic. But when they were combining the antibiotic and the symbiotic, the mortality increased. So that has implications on the production system, because if your fish is ill and you are feeding with antibiotics, be careful with the health package you are feeding also, because there can be an antagonist. It's not always the case. Here is the case with banane, with a symbiotic that is working perfectly against Vibrio henolyticus. The prebiotic already reduced mortality. The probiotic even reduced it further. And when they were combined, it was reduced significantly compared to the prebiotic. So there are some cases that this is a synergy, but there are others that is an antagonism, and it has to be taken in mind. So to finish, I would like to leave you with two take-home messages. The first one is that functional feeds are a proactive strategy for this disease management, and it can be useful. But take in mind that you always must culminate your strategy on a reliable administration for the aquaculture sector. What you are working on is in giving a solution or an extra tool to the sector to solve a specific problem. So we are working for the sector, and we have to be aware of the needs of the sector to align with their needs, our research. My second take-home office is that this master's in aquaculture, for me, it's it's an excellent academic program. You can check it on the web, but it also, you will have it offers an outstanding scientific support, excellent facilities. You can see the facilities at the University of Las Palmas are excellent, labs and also aquaculture facilities. And it gives you the opportunity of build a strong network with professionals of this sector in a very inspiring environment and international, thanks to the CIHEAM collaboration and the students that came from abroad. So take in mind that you will have the chance to meet classmates who will become key professionals in the aquaculture sector. You will build your own network in this master's, and this master was 20 years ago probably, but it made a significant change on my way of doing research, and for me it changed my life really. So thank you very much for your attention, and I will take any question you will have.
Okay, thank you very much, Silvia. Thank you very much, Rachid and Mohamed. Now we have some time for questions, let's say 10, 15 minutes, no more, because we are a little bit delayed. I don't know if you have the time to look at the questions and answer. I think that Mohamed and Rachid have already answered something. I don't know, let's start by Mohamed, because you got some questions before. You would like to say something about the use of artificial intelligence in formulation or how the industry is using that tool?
The industry, as all the industry today, I think we are working in a world that is going too fast in using data and using artificial intelligence, and this is, if we are not in this trend today, we will not catch up, mainly. I can say that all the company today are trying to use these resources to improve their feed performance, but not only feed performance, but also I can say the sustainability of the feed and the aquaculture in general. No, is not only the feed or feed company are using this tool, but today we are working with the majority of the biggest company in producing fish in Norway, in Chile, in some places in the Mediterranean area, that they are using AI to understand the behavior of their fish. They're using AI to manage their fish the day to day, and to understand when they are eating more and when they are eating less. And we are taking advantage as the feed producer from this data to improve our formulation based on the behavior, based on the growth, based on all this data that we are able to analyze, and with the AI faster and also more precise. No?
Mm-hmm. Okay, thank you. Don't know, but thereafter I will make you, for all of you, a question about the aspects about how climate change is affecting your research or area of work. But let me go to Rachid. Some participants have asked you about the use of insect meal and other alternative ingredients. But let me remind the participants, one of the first slides by Rachid. 20, 30 years ago, we were very worried about the limitations of using fish meal and fish oil. Nowadays, that is not a main concern. It is for some aspects, for certain moments. Now we have concerns about whether these new alternative ingredients that are being studied are going to be really a reality, no, in the future, in the commercial use or not. My question is going in that way. So you have made a good revision of alternative ingredients, no, research and how they are going to the market. But I asked you, well, I pointed out something that you haven't had time to talk, is that the use of some alternative ingredients are limited by regulations. Can you say something about that?
Yes, sure. So these novel ingredients, of course, there is a lot of research going on, but also, as you rightly mentioned, the legislation has also to follow up, so to approve these ingredients as quickly as possible. This is happening for some. For example, insect meal is approved in Europe for all species, including for poultry, etc., because it's in line with the circular economy concept coming from the Green Deal since 2015. So we have realized that having our food production system depending on this world supply chain, we have learned in COVID that when the supply chain breaks down, then we are really in a serious trouble. Okay, so everyone is moving forward to a more sustainable circular economy systems where we can have our own ingredients to produce our own food, and this goes down to food security, right? Which is we have learned it also through the Ukraine-Russia war, where we have shortage in terms of supply chain of these ingredients coming from Ukraine and Russia and all that. So we need to move forward to a more circular economy, sustainable systems where we can produce at least some of our ingredients. And one very sustainable way is to how can we convert waste, which is already we are producing 40% of our food that we produce is wasted. So how can we bring back that food wasted through some natural biological models that are happening in nature? That's what insects, for example, are doing. They are converting this organic waste to protein when they grow, and it's happening in a short period of time. So compared to having, soy protein, it takes months, but these insects in 15 days, they can grow 5,000 times from these tiny eggs, right? And doing it, converting organic waste that is already causing us also all kind of issues in terms of environment. So this is a very win-win model in all ways. And how can we take that to scale it up to an industry level where it can produce sustainable, high volume, consistent product? So insect meal is well, published in the literature that its digestibility, the amino acid profile, all these claims are comparable a little bit to fish meal, and also it gives them this sustainability checkbox that they can add. Now, the problem is the scalability, the volumes, the price, of course. So that's where you need to consider these insects as animals. So we need to formulate what kind of weight we use for them so that we have consistent finished product, okay? So that's why the most successful insect project, these insect plants are next to another plant that is producing a consistent organic waste in an industry level. Because if you just are collecting waste on a daily basis, that's not consistent, that's different from day to day, it's not gonna happen. If you have to have a consistent industrial waste at a volume to give you a consistent finished product at a volume. And then all these automation, genetics, and all these other tools can help reduce the cost. Sorry if I elaborated too much.
No, you did it very well. Something for Syria, just to let you know, I don't know, you have seen a lot of hearts and closes when you were finishing your talk. So it seems the participants follow you with very high interest. I read something about the research on fish additives and about the length of the experiments. Whether the length of the experiments that you are normally using, 8 weeks, I think they say, is this enough or is maybe too short?
Oh, yeah, well, I was trying to answer on the chat, but they have to take in mind that normally this kind of product are those time dependent. I mean, depending on the sector, for example, now with the prediction of heat waves, we are increasing the dosage and reducing the time, because with this prediction, we can give an acute pulse of this additive, preparing the fish for that heat wave. But when you are looking for an immune modulation of the fish, normally 8 weeks, it's enough to modulate the microbiota and to establish, to change the autochthonous microbiota of the fish. And also in many cases in Europe, we run trials between 8 and 12 weeks because they are the requirements of the European Agency for additives studies. So, but yes, you can adapt depending on the species and on the need. As I told at the end of my presentation, we are using feed additives as a tool, complementary tool, to give a solution to this sector. So you can adapt with the dosage and the time you are supplementing them.
Mm-hmm. And according to your knowledge, Silvia, what additives are the most frequently used by the industry? I don't know if you can answer that question, or maybe Mohamed. Just you can highlight us if they are using new oils? Or...
From the research point of view, we try to work independently with one of them to try to define the mode of action. But I'm aware that these are introduced in health packages in the diets. So probably they are used combined. And that's why I'm kind of sending a message of awareness, in particular with antibiotics, because we must reduce the use of them. I mean, some guys that are antagonists with this kind of feed additives, feeding together with antibiotics. Then we are not giving the solution to the sector if we are feeding both together. So I don't know, Mohammed, but for sure you are combining.
No, yeah. I think all, as you are saying, the correct word is the mode of action, no? And there is no issue, no pathology, or no problem in the fish or in the shrimp that have only one thing happen in the fish, in the physiology. There is a lot of pathway that are impacting at the same time. And if you are using prebiotic, or you are using postbiotic, or nucleotides, or whatever, is not enough to handle all these pathway. That's why in the industry general, in Cargill, in our side, we are using a combination of different additives to really target each one of the pathway. And one thing more, I think health, or this health issue, not usually are how to solve it only by additive. No, nutrition is the first pillar to change everything. And when we are speaking about vitamin, mineral, when we are speaking about this cofactor, this is the first, I think, way to solve the problem. Yes, plus all the additives that are not a commodity, I can say. Sorry, they are not super thing that we are adding because we want to add it. No. This is now starting to be a commodity to include organic acid, or to include prebiotic in the formula, because we are reducing fish meal, we are reducing fish oil, and we need a compensation for that, not for the performance, but for the health perspective and robustness. No?
Yeah.
Okay, I'm going to make a general question for all of you, and then we will have to finish. But you, Mohammed, you have spoken about precision farming, precision nutrition. Sylvia about additives, Rachid about new ingredients. So we might think that the nutrition is becoming very complicated. I don't know if for the feed manufacturers, for the researchers, but also for the farmers, no? And you are talking about precision farming according to environments, according to production sites, and this in a moment that we are challenged by climate change. So we may think that the world is becoming very complex, but I don't think that is more complex than 30 years before. The constraints that we faced 30 years before were very serious, and now we have other constraints that we need research. But anyway, my question is related with this climate change. Under your point of view, what are the main challenges that you are facing in the industry, or what do you think? If it's for the producers, for the feed manufacturers, for the farmers, for researchers?
For all.
For all.
Is for all. For the farmer is mainly the temperature fluctuation. This is something that is impacting directly the immune system, and really have a big impact in fish in general. That's why when you are seeing problem, you are seeing usually when we are changing season, or we are having a big fluctuation, we are seeing pathology and bacterial opportunistic virus, etc. This is something really, really important. Is impacting feed producer also, because we need to understand the market price, the market availability or the ingredient availability, and this is really important for us. And with this climate change, prices and quality also could be impacted by that. No.
Yeah, I think, Bernardo, that we have to understand how is the response on the host, because it change the host responses. I mean, when you're increasing temperature, the composition of lipids in the tissues are changing because of the flexibility, and that must be accompanied by the change on the formulation specifically for that event. And then once formulation it's adapted to that, then we can reinforce with the additives. And all this within a sustainability context, because we have to manage with what we have and the prices we have in the market to formulate according to the needs. So I think it's a quite challenging scenario for the feed producers also, but also for researchers, because we have to understand what's happening in the host to try to help the sector some way.
If I may just chime in. So I think in terms of climate change, it's a problem that nobody can solve by themselves. So this is why I think it's a collaboration project for the industry. That's why we see these coalitions coming together to target some aspects of reducing their impact as an industry on the climate change. For example, we have seen some very beautiful scenarios where you would see these feed manufacturer competitors sharing the same vessel to deliver the feed for their end customers. So this is something that it's going to grow bigger in the near future, and trying to look to the big picture and targeting climate change as a whole industry, forgetting about the competition, etc., because it's a problem for all. And if the industry itself can, through these coalitions, reduce the impact of the whole industry, it's a win for everyone. So I think climate change, answering your question, is going to be a collaboration, a coalition as an industry, investing in R&D, investing in ways where we can reduce all our impact. And there are challenges that's going to be bigger than anyone, so we need to face them together. Biosecurity is another one. So I think it's going to be a different mindset to change how we approach sustainability and climate, facing the adverse effect of climate change as the whole industry.
Okay, thank you very much. I'm sorry for the participants because I see that there are many questions, but we have some time limitations. And now we are going to start the end of the webinar by introducing the master that we are coordinating. So give me a second. Do you see my screen? No, I don't know what you see.
Need to make it bigger, I think.
Yeah, just 1 second. Okay. All right. Feliz, it's okay?
Yes.
Okay. So let's make a short introduction to the Master in Marine Aquaculture. As I've been speaking for a while, I pass the floor to Feliz. I will pass in the slides. Would you like to start, Feliz?
Okay, you can start and then pass me.
Okay. Well, you know me, I'm Bernardo Basurto from the CIHEAM Zaragoza, and Feliz Acosta professor of the University of Las Palmas de Gran Canaria and the coordinator of the master. So let's say why to choose this master is something that has been already addressed by your guest speakers. But one of the reasons is that in this master you are going to have the opportunity to get lectures from more than 40 lecturers, not only from the University of Las Palmas or Gran Canaria, but also from universities, research centers, and companies from other countries and other areas of Spain. And for the participants, we know that it's a great opportunity to interact with colleagues from other countries, from other cultures, something that can give you the opportunity to create a network of colleagues in your future career. The program is, in my way, an innovative multidisciplinary program with updated contents based on a scientific and technological basis that support the development of aquaculture. And for the participants, we think that is a really good way for the initiation to research. And let me point it out because aquaculture, as you have seen, is a specialty based of scientific knowledge. And the scientific knowledge is driving to the farmers, driving to the feed company producers. This is a very innovative area, an innovative field, and this is very important. That anyone that wants to be a specialist in aquaculture, they do a good specialization postgraduate. And well, finally, the master it has award by the official Spanish master's degree, and besides the Master of Science award by the CIHEAM Zaragoza, by the CIHEAM. Felix, this is like for you.
Yes, when they finish, they have a lot of possibilities to work. We have now 3 examples. One in the university, go to the industry, back to the university. Mohammed in the industry, and Sylvia was in the university, and now is in the research centers, but also in companies or different. You can work in different private or public company research centers, or also for the governments. Also, we have people that are working for the governments, because the formation during the master is not only aquaculture as a growth fish, is only to planning the cost, to planning the installation, the nutrition, pathology, reproduction. You learn about the whole, or in general, aquaculture.
Okay. Well, it's a master that has been offered more than 30 years ago. It's offered every 2 years. It's an official master of the Spanish university system, as I said already before, and it's structured in 2 academic years. In total, 120 European credits. The first part is a first academic year with different subjects from October to June, and the second is devoted to the initiation of research. What you see here is the subjects that are taught in the first academic year: introduction to aquaculture, nutrition, health management, reproduction, engineering systems, economics and management, hatchery production, on growing techniques, culture of different species, environment. And the second year, Felix, you can explain.
And the second year is a year that dedicated more to finish after the theoretical formation in the first year. This is a really practical year, because the students go to the labs to do the final job of the master. And also we offer different themes about the pathology, nutrition. But if you are interested as a student in industry, or to do in other field, or even in other country, we have some students who finished the second year in Hawaii some years ago. so that you can choose if you decide to go to other country or to other university or to other research center. We will help you to find all the permissions and the contacts and everything to finish this second year.
Very briefly, admission. To participate, to be admitted at the master, you have to submit your pre-registration, and then some of the requirements is a university degree, preferably in agronomy, marine science, biology, biotechnology, veterinary science. You also need to know Spanish, because Spanish is the main working language of the master, and for international students that they don't know Spanish, the CIHEAM Zaragoza organized an intensive online Spanish course from July till the end of September, in order to allow them to reach the minimum language level, which is the B1. Understanding of English is also taken into account in the admission, and there is a registration application page at the University of Las Palmas of Gran Canaria. At that page, you can find the pre-registration periods. The first one is going to be open very soon, no?
Yes, middle of April.
Middle of April. So it's very easy. You just write pre-registration, university pre-registration for masters in the University of Las Palmas de Gran Canaria in Google, and then Google drives you to the web page. If you go now, the pre-registration is not open, but it's going to be open very, very, very soon. What more? The organization, we offer us, let's say, a significant number of grants. This year we have grants coming from CIHEAM countries, which are Albania, Algeria, Egypt, France, Greece, Italy, Malta, Morocco, Portugal, Spain, Tunisia, and Turkey. And also, thanks to an agreement that we have with the Spanish Agency for International Cooperation, we can offer some grants to other Arab countries not belonging to CIHEAM, as for example, Jordan, Mauritania, or Palestine. Let's say that the preference is going to be given to low and middle income countries, not to European or high income countries. And the applications for these scholarships has to be made to CIHEAM Zaragoza. You have there the admission. And then for other countries, we are sorry, but we cannot offer scholarships. But you have information at the webpage of the University of Las Palmas de Gran Canaria. And also the second year, the students, they have the opportunity to apply for mobility grants. And maybe, Felix, you can say something about the grants that are managed by the university.
Yeah, mainly we have, as you see on the slide, we have two different from the Spanish Ministry of Education, and also Erasmus Plus, that is provide fellows to make. This is for short period, not for long period. Most of them. Some of them sometimes have covered whole year, but it's not the most common. It's about 3-4 months of mobility.
Mm-hmm. Okay, let me say something that I think that is important. Maybe some of the participants, you haven't finished yet your university studies, but you are going to finish. And you see that deadline is 4th of May. Then what to do? Then what you should do, if you want to apply, is apply, present the university records that you have at the moment of the submission of the application, and then we will know that some of the grades are pending, because maybe you will get it in June or July, and sometimes that there are students that finish their career with the final project. But that we will take it into account. We know that reality, and that's something that we can consider anyway. Well, that is very important. Let's see. Just to remember dates and deadlines. The first year of the master will start in October. It's from October to June. And the second year is normally from beginning September, October, and it lasts for 10 months and finish with the defense of the master's thesis, normally in June, July, or maybe beginning of September. There are several dates. Well, the pre-registration deadlines, as we said before, are going to be published at the webpage of the University of Las Palmas de Gran Canaria. That there are 2 application periods. The first one is going to be open very soon, the 15th of April, most probably. And
this year is only one.
This year is only one.
It's only one period, but they start in April and don't close till June. And in June finish to evaluate all the prescription to elaborate the list of people admitted to the master.
Mm-hmm. And as I said before, the applications for scholarship award or managed by CIHEAM Zaragoza have to be submitted by 4th of May. And just what we look when we evaluate the applications, we look at the academic records, knowledge of language, we look for motivated students eager to begin a new specialization. And that's the way that we do our selection. And I think that's all. I don't know. Well, I think that there might be more questions, but let me tell you for the participants that the university, they have a web page about the master. There you have the details about the program, details about the master. At CIHEAM Zaragoza, we also have in our web page a lot of information about the master. So read that information and consider the possibility of applying for the master. Okay. Felix, I don't know if you would like to say something before we end?
No, I think only say thank you to everybody that attended the webinar. A lot of people attended, and I hope most of them have interest in come to Gran Canaria to course the master. And all of you, we will be very pleased for us to take here about for 2 years to enjoy the environment of this master and to learn a lot about aquaculture.
Yeah, well, and just one last thing is, well, this is a joint master between CIHEAM Zaragoza and the University of Las Palmas de Gran Canarias. The reason why the master is in Las Palmas and not in Zaragoza is clear, is where there is the sea. The weather is much better than in Zaragoza. And they are open people, welcoming. They welcome, I know by experience, the participants from all the world. They treat it very well. Well, for me, I know, so something that I wanted to point it out. So again, thank you very much to Silvia, to Rachid, and to Mohamed to participate in this webinar and to collaborate and for collaborating with us. So
thank you so much.
You.
Good luck.
Good luck,
everyone.
Bye-bye.
Bye.
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 Thank you. Bye-bye.